Hey guys! Oh, it's nice to see everyone on the chat. Nice to see Jack and Zina contribute on the chat there. That's great. I'm just going to quickly pause the other video on my other screen because it's about to come through and it's going to come through loud. Give me 1 sec. That's if it decides to work. There it is. There we go. Pause that. Amazing. Right, guys, we're in. Okay, so I'm going to share my screen. It's not going to take me very long to go through all this anyway. Cool. There we go. Then go for that one, because otherwise you're looking at my screen. Go. I like it. Okay, so this is the test that you guys have just done. As I said, I know that you don't have the tests with you, but it's nice that you've got your percentages and your scores. And you'll have a rough idea of the kind of things that you've written down. But I will then scan you. As soon as I've gone into school, you can go in, I'll scan in your papers and send them all out to you, and then you can review the test again if you need to. Okay, so question number 1 was about diffusion and the element bromine. So really nice this. So bromine, group 7, is a liquid at room temperature, but it's very, very volatile. Now the word volatile, it's always nice for you guys to, just going to check that everything's working in this, and because I feel like people are now sending messages saying there's a problem. Oh, Julius wanting the link. I like it. I think everyone's in now. Cool. Okay, so bromine is a brown liquid, turns into a brown gas. As I said, it's got a very low boiling point, so it tends to evaporate really quickly. It says which of these processes that causes the brown gas to fill the jar. I'm going to mark this in red. So to fill the jar, that's the key one, to fill. I'm actually realizing that I should probably actually highlight. It's the to fill. Yeah, to fill the jar. And the answer to that one is diffusion. Yeah, I'm going to make my pen a bit thicker in this situation now. Boom, boom. There we go. Whoa, that's now crazy thick, too thick. Okay, try that one. Cool, diffusion. So evaporation is what allows it to start the process of spreading. So it evaporates at the beginning and then diffuses. It then says, explain using particle theory the observations seen in the jar. So the first part of this is to go from here to here, it needs to evaporate. So the first mark of this is to say bromine. This is the one that most students missed. Bromine evaporates. It evaporates, forming. Is that how you spell evaporate? It is actually. Is it? Oh, yeah. Evaporates. Evaporates. It's nice to give you an equation for this, and that equation is Br2 liquid goes to Br2 gas. That's the evaporation. It's just a state change. So it's just a state symbol change. So the bromine evaporates, there's 1 mark, and then the bromine gas diffuses. Now that's not enough to get you the mark. Diffuses, spreading from an area of high concentration. An area of high concentration to low concentration. There we go. The gas diffuses, spreading from an area of high concentration to low concentration. I like it, second mark. Moving on. Okay, next one. The apparatus is used to demonstrate the movement of ammonia gas. We see this a lot at Edexcel. They love this question. So we see the formation at C. Now, the reason for that is because HCl has a relative molecular mass. Hydrogen has a mass on the periodic table of 1. Chlorine is 35.5. So the total for HCl is 36.5, whereas ammonia, which is NH3, nitrogen has a mass of 14. Hydrogen has a mass of 1, but there are 3 of them. So that has a mass of 17. So what that means is the hydrochloric acid gas, the hydrogen chloride gas is heavier, has a bigger MR, so it diffuses at a slower rate, yet the particles are moving more slowly. And it says the gases are given off in the solution at each end. When the gases meet, they form a white solid. Which letter shows the position where the white solid forms? And that's C. Now, of course, they flip these all the time. So you just have to be aware that this one's the heavy one, this one's the light one, and you just need to make sure that you go to the side closer to the heavy. Next. Okay, this question was an interesting question because a lot of students made mistakes on this. So they've got 4 substances A to D with different melting points and boiling points. And each question, so I just said, what is the state of A at 25 degrees Celsius? So if I go, so this is A, and A has a boiling point of -125, and a melting point and a boiling point of 0. 25 degrees Celsius is above it. It's way up here. So what that means is we've got solid, liquid, gas. So first of all, the first state is going to be a gas. Yeah, it's already boiled by this point. Next one, it then says, what state will B be at 93? Okay, so B, I'm just going to draw my line again. B has two temperatures. So B has a melting point of 70, a boiling point of 200. Where is 90? 90 is about there, at 93. So this is solid, this is liquid, and this is a gas. So it's in the liquid phase. So we know B is going to be a liquid. So what is the state of C? So C, two temperatures. C is 11 and 83. And they've said 9. 9 is right there. So it's in the solid section. So this is going to be a solid. D has two temperatures. D is -80 and -110. They've asked at -879. Now that's the trickiest one there. 79 is right there. Yeah, that's -79 because we're moving up towards 0. So that means it's in the liquid phase rather than the solid phase. Clever question, that one. So that one's going to be a liquid. So the answers were gas, liquid, solid, liquid. Yeah, and that kind of makes sense. They're looking to test each one, each understanding of each particular state and checking that you're able to use your thermometer line. Yeah, I hope that made sense. If you've got any questions, please lob it on the chat. It's always the best thing to do is to draw that line. I know it seems crazy to do so, but in reality, the line is always useful because it allows you to identify which gap it's sitting in, and it makes it a whole lot easier. It stops you making mistakes. Next question. State how the diagrams show that both, this was a key thing here, folks, both of these atoms are neutral. So what you needed to say was atom 1 and 2 have, right, let's count them. 1, 2, 3, 4, 5. 5 protons, 5 positive protons. Yeah, and 1, 2, 3, 4, 5 negative electrons. So 5 minus. So what that means is 5 minus, they're equal. Same on the other one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Atom 1 and 2 have the same number. I won't do that. The same number of protons as electrons. So the charge cancels. Yeah. We remember that if we've got 1 proton and 1 electron, that is neutral because the 1 minus cancels out the 1 plus. However, if I have 2 protons, yeah, the neutrons don't do anything, but I only have 1 electron. What we means is this is now not balanced. This is now going to be x plus 1 because I have 1 extra positive than negative. Yeah. Next. So it's about this idea of the same number of protons and electrons. Explain how the diagram shows that these atoms are isotopes. It's the definition of isotopes. So they both have the same number of protons and electrons, but atom 1 has 5 and atom 2 has 6 neutrons. And you had to use the diagram. Atom 1 and 2, atoms 1 and 2 have the same number of protons and electrons. 1 mark. 1 mark. I'm suddenly realizing that Lauren needs this to mark. Let's tell you how the diagram shows that. Atom 1 and 2 have the same number of protons as electrons. 1 mark. Yeah, you need the comparison though. That was the trap. Atoms 1 and 2 have the same number of protons and electrons, but, and this was the tricky one, the second mark was the hardest. You had to give the numbers. Atom 1, I'm going to change my color. Atom 1 has 5 neutrons, but atom 1 has 5 neutrons because it says, explain how the diagram shows. I've put neutral because I'm an idiot. Let's get rid of that. Come on, little laptop. There you go. It has 5 neutrons and atom 2 has 6 neutrons. It was a clever game that most people forgot to use the diagram. Next, complete the table to show the atomic numbers and mass numbers for atoms 1 and 2. Perfect. So atom 1 had atomic number of 5 because of 5 protons, but now it also had 5 neutrons, so its mass number was 10. The atomic number of number 2 was 5 as well because it had 5 protons, but it had a different mass number of 11 because of its additional neutron. 2 marks, 5 and 10. Next, right, calculate the relative atomic mass of whoever it is in the table. So we've got, it's going to be 6 times 7, close brackets, add that to 7 times 93, all divided by 100, and it's going to be really close to 7, really close. And here was the trap, 1 decimal place. Loads of people gave it to 2. About half the class gave it to 2. 6 times 7, I've got to use brackets, I'm on my stupid phone. 6 times 7 plus 7 times 92. I've forgotten the bracket. Bracket 7 times 92. Right, divide the whole thing equals, divide the whole thing by 100 because it was a percentage, and I get an answer of 6.9. Loads of people put 86 and you lose it because it said in the question 1 decimal place. Clever game. Next. This question is about the elements in group 1 and the periodic table. Reactions with water. State why sodium and potassium are in group 1. So group 1, they have 1 electron in their outer shell. They both have 1 electron in outer energy level. Outer energy level. Done. That decides your group number. Next. A reaction occurs when a small piece of sodium is added to a large volume of water. Give 2 observations that you would make during this reaction. Fizzing, or effervescence if you can spell it. Fizzing, it disappears, it floats. Now, it does say give 2. Please make sure that you just give 2. Lots of people were listing them in these lines. They will only mark the first one you write down. It is 93. Zina says 93. Have I done something wrong? What have I done, Zina? It is 93. What have I done? What have I done? What have I done? What have I done? You can also say it darts around on the surface. You can also say that it melts into a ball. You can also say that it disappears eventually, that eventually it will disappear. After the reaction is finished, a few drops of universal indicator are added to the trough. Explain the final color. So, final color, purple, 1 mark. Because it forms sodium hydroxide. That's actually not the mark, funnily enough. Hydroxide, which is an alkali. You're done. Well, Cal, you kept on saying 92. Did I? Did I say 92? What did I type in on my calculator? Don't know. So 6 times 7. Okay, I'm going to do this probably again. I'm going to do them on count. 6 times 7, close brackets, plus brackets. 7 times 93, thank you, Zina, equals, divided by 100, gives me 6.93. Thank you, Zina. I made a mistake. Lots of people did that. The answer is still 6.9. Whee! 6.93. But then, of course, when you drop it down, it must be to 1 decimal place. Thanks, Zina. I got it wrong. I'm just not reading the question. RTFQ, read the full question. What is the most likely pH value of the solution in the trough? 12. Alkalis are high, guys. It's not going to be 8. 8 wouldn't be purple. 8 would be like a pale, it would be a funny greeny blue color. It'd be a nightmare, that. Pale blue. Give the name of the group 1 metal, which is less reactive than sodium. Lithium. It's only 1 there then. Isn't that nice? Lithium. We know that because it goes lithium, sodium. What am I doing? Lithium, sodium, potassium. As we go down, they get more reactive. Well, there's only 1 metal that's less reactive, and that's lithium. Mr. Duncan, Lauren is asking if she has to send the test before marking it or after marking it. No, she can just send it after she's marked it. I don't mind. I trust her. I trust Lauren. She's nice. A small piece of potassium is added to a large volume of water. Give one observation that's made with potassium, but not made for sodium. You will get a lilac flame. Woo! Done. Next, balance the equation. Right, a load of people really struggled with this. There is one rubidium. There is, divide the thing in half, one rubidium. There is two hydrogens. There is three hydrogens. Right, so hang on a sec. The problem is, the only thing I can do is double it. Yeah, so I'm going to put 2 there. But if I put a 2, now I've got 4 hydrogens. And I've only got 3 over here. So I added 2 there to get me 4, because that one's got 2 in it, that one's got only 1. So if I double that, I get a second one. Yeah, most people got this right, by the way. And then I've got 2 rubidiums. So then I put 2 rubidiums, and now it balances. So the final answer was 2, 2, 2, 1. Just a game. It's just another game. Next, right. In the table shows that she did not do the experiment. Suggest why she did not do these experiments. Because bromine won't react with bromide. Yeah, and chlorine won't react with chloride. And iodine won't react with iodide. Yeah, so she's not doing the ones where they're the same. So we state, we'll suggest why she don't do these experiments. The halogen, remember, halogen is these guys. These here are the halogens, underline gens, diatomic. And these are the ides. Yeah, these are the halides. Now, you could have used an example here if you'd like. You could have done this. But the halogen won't react with its own halide. Now, that's me putting it in fancy chemistry speak. You can do another option. You could have just simply stated, which is much more common for students, for them to say, bromine won't react with sodium bromide. Whoops, my laptop's being funny. Sodium bromide, same group 7 element, same reactivity. Same reactivity, same applies to chlorine and chloride, I'll be good, and chloride, and iodine and iodide, So I'm trying to keep it short, but what you needed to do is you needed to state that the element won't react with the solution of its halide ion. You just need to say there will be no, because they have the same reactivity. It's that idea of them just being the same reactivity, so there's no point in doing them. The table shows that there was no reaction in the 3 elements, in the 3 experiments. Why was there no reaction in these 3 experiments? There was no reaction in, okay, so hang on a sec. We've just done the not done. Now we need to do the no reaction. Right. So why was there no reaction? By the way, again, you could have chosen an example. So bromine won't react with lithium chloride because bromine is less reactive than chlorine. Done. Iodine is also less reactive than chlorine and bromine, which means it won't react. You can get the point. Yeah, but it's the idea that the halogen is less reactive. It's really hard, this, especially when there's such little space. The halogen is less reactive than the halide in the solution. That's the posh way of writing it. As I said, you could have gone to town on that. And I know that it's tricky, that, because the space is so limited. I'd quite like to give more space for that, for students to have the option of getting more marks, but it was a clever question. As I said, you could have given an example of it and you still gain that 1 mark. Yeah, just choosing an example, pulling it out works. Right, Students giving you this, bromine reacting with potassium iodide to form what? Potassium bromine? No. I have to give the correct name of this substance, potassium bromide. We remember that the non-metal changes its name. Instead of being bromine, it'll become bromide. And of course, there's a hint in the question. Iodide becomes iodine. It's going to be the reverse for bromine in that situation. Should be used highlighters more. Bromine. There's the error. Should have been bromide. But it's nice, the hint of iodide becoming iodine. Next. Finish the equation. This was tricky. Yeah, it was hard, this. So the first thing is to realize, right, the chlorine is more reactive than iodine. So it's going to switch. I'm going to form KCl. Now it's going to be the same formula as the Ki. Yeah, because they're in the same group. But then I'm going to form I2. Remember, anything ending in -ene, yeah, is going to be diatomic, ene or gen. And then that's 1 mark. 1 mark for these guys. So tick 1 mark for that one. Tick. But then you had to balance it because 2 chlorines went in, but only 1 chloride came out, so double it. 1 iodide went in, 2 came out, so there's the balancing for the second mark. Hard, that. Now, I know that we haven't done formulae. I do understand that, but it's the idea of just swapping them and making the formulas the same. Yeah, there was a trick to that question which allowed it to be used. Next, right, separation techniques. So we've got ink from colored inks. Yeah, chromatography all day long. Yeah, you've just got to know that one. Separate inks, we use chromatography. Ethanol from a mixture of ethanol and water. Right, that's 2 liquids. That means it's going to be fractional distillation. You wouldn't use simple because you're not going to get a good enough separation. To separate 2 liquids, you use fractional. Sand from a mixture of sand and water, filtration. Water from a copper sulfate solution, that's simple distillation. It's simple distillation because you want the water, yeah, but it's a solid dissolved in it. It's not another liquid, so you can just use simple. Which of these mixtures contains an undissolved solid? It was sand. Next, pure dry crystals of magnesium nitrate can be obtained from magnesium nitrate solution by crystallization. Give the steps in order. Right. So what we want is we've got a solution. I'm going to do it in black. Switch to black. We've got a solution containing copper sulfate, CuSO4 aqueous. We want to get rid of the water. Now it says that step E comes second. So we can ignore that one from the list. But it says dip a glass rod to see if crystals form. Right, so first thing I need to do is I need to evaporate some of the water away. Let's get rid of some of the water. So where's that one? Heat the solution to evaporate some water. There it is. So that's B. Yeah, once we've evaporated some of the water and the crystals form on the glass rod, now we're going to leave it to cool down. Allow the solution to cool down. That means that crystals will now form because it's past saturation and the crystals will form. Once the crystals have formed, I now need to get the crystals out. So we need to filter out the solid. So that's C. And then the last one is put the crystals in a warm place to dry. D. Tricky now. Next. Explain which 2 boxes represent an element. So obviously, first mark, box 1 and 2. So these guys are our element. Now we need to explain why. And this is the definition of an element. Both boxes contain only one type of atom. You could have alternatively simply said box 1 contains only helium atoms and box 2 contains only hydrogen atoms. That would have also been accepted. Next, which ones represent a mixture? So a mixture, done our elements. Mixture, box 3 is a mixture and box 5. So why is that? Because box 4 is still pure water. There's only water in there. Whereas box 6 is hydrogen peroxide, that's pure too. But number 3 and 5 contain different people. So first one is box 3 and 5, 1 mark. The next one is to explain why. And what we say is box 3 contains helium and hydrogen. Helium atoms, nice to do that even further. They're atoms because it's all on its own, noble gas. And hydrogen molecules. Hydrogen molecules that are not chemically bonded. You can actually just simply say they contain particles which are not different particles that are not chemically bonded. That's also allowed. You could get the whole marks from that one. Box 5 contains hydrogen and water that are not chemically bonded. As I said, the chemically bonded. You could also say contains particles, different particles, contains different particles that are not chemically bonded. Next. Is that the end of the paper? We're done. That's it. 40 marks. We're finished. Amazing. Right. I'll switch back to me. Right. Guys, that's the end of the test. Nice quick test just to quickly run through. I hope that made... Oh, really hot. I haven't got the air conditioner. I hope that made sense. I know that you guys haven't got your paper. I get that. Don't worry, you can always watch the video. Great thing about YouTube is that the video is saved. You can always watch back the video once you get hold of your paper. I will pop into school and go and try and pick them up, and then I'll scan them in and send them over to you guys. Guys, I hope you have a nice rest of your day. I'll see you soon. See you on Tuesday. See you later.